Stanford University.
Lecture 4 of CS193P. Welcome once again. Today we're going to talk a little bit about how to get into the guts of building an application, real-world creation of an application, which we introduced you to a little bit on the first day, last Tuesday, but it was kind of a made-up example. We'll start looking at how to really build an application today. We'll look at another design pattern called Model View Controller. We'll take a look a little more in depth at nib files and interface builder. And we'll talk some more about controls and target actions. So first, some announcements. First off, we have tomorrow's Friday session is all set up. It's from 4 to 5. And the room will be 260-113, building 260-113. Hopefully you all know where that is. I believe that's going to be our weekly location from now on.
That's my understanding, yeah.
Okay. If it changes, we'll let you know, but for tomorrow, this is where to go. And I think, so David and Paul are going to take you through Xcode debugging and
just sort of walking through building a basic app and debugging along the way and afterwards and that kind of thing.
So, good one to go to. The debugger you'll use fairly extensively throughout the course, so I would encourage you to go get familiar with it now. If you are enrolled in the class, we'll be sending out invites to the developer program by this weekend. And once you receive that, you'll get a message that you should go to this website and fill out, I forget what it is, you have to send in a certificate, and then you'll be able to develop for a device. So that's exciting. You'll be able to actually upload your apps onto your phone or iPod Touch. And we're waiting for a couple of students to reply about 2 pass no credit spots that we have for the class. If you're in this room, please reply. Otherwise, we're going to give your spots away, probably by the end of day today. So once again, today's topics, we're going to look at the application lifecycle, which we talked about a little bit when we talked about auto release on Tuesday. We'll go into the model view controller design pattern, which is used extensively through Cocoa development and should be used extensively through all your application development going forward. Interface builder and nib files, how to set up your views, control and target action, and we'll talk a little bit about Hello Poly, which is the assignment 2B. So first, a little review from last week. First, I want to talk about memory management. So as you may remember, as I hope you remember, alloc and init are the ways that you allocate memory and initialize that memory. Init sets up the NS object and sets up your object if you have a subclass. NS object will clear the space for you, so it does a lot of initialization that will help you. And what you want to override in your initialization is the init function. And of course, you can have designated initializers that are more complex, but you don't want to override alloc. Retain and release, the way that memory management is managed on the iPhone OS and on the Mac is through retain counts. So when you retain or alloc, your retain count goes up by 1. When you release, your retain count goes to 0. And it goes down by 1. And when you get to 0, it'll call dealloc. Don't call dealloc directly unless you're subclassing dealloc to do your own memory releasing. And auto release will help you release memory when a run loop completes, so allow you to defer memory release. Setters and getters. So we talked about the structure for setters and getters. They're always like this. You have you return the value type, and you name it based on your property. And to set, you return void, and you use lowercase set followed by the uppercase first letter of the property, and then you pass in the type for that property. And properties, of course, are a quick way to do setters and getters. It's a convenience method in Objective-C2. You use synthesize to generate those, and here's a little example. So before I move on, actually, are there any questions about this stuff? Memory management, allocation. Setters and getters. Great. OK. So let's look at how to build an application. Inside, when you compile your application contains a number of different files. It will contain your compiled code, which is the executable. It may contain frameworks, although on the iPhone that's not necessarily true. On the Mac, you may have embedded frameworks. But what your app does do is it links to frameworks that are built into the OS, such as Foundation, UIKit. You may have, if you're doing audio, there's audio frameworks, there's video frameworks, stuff like that. Inside of your application bundle, which is this package that contains all the files necessary to run your application, there will also be the nib files. And the nib files are the UI elements for your application that are pre-laid out. And details about the object relationships. So your nib file will describe a few different objects and will tell each object how they relate to each other. And your app will also have resources. So if you have images, very frequently you'll have images that you want to include for custom views. If you have sounds, stuff like that will all be part of this bundle. And every application also has something called an info plist, which is essentially, it's an XML that describes some basic functionality or some basic parameters of your application. We'll look at some of those parameters in a little bit. We saw this when we talked about auto release, but I want to bring this up with respect to how an application actually runs. So when somebody presses your app's icon on the home screen, it launches the app. And it does some initialization under the hood, nothing that involves you yet. But at some point, you're going to get called with a message to say that your app is initialized. Now you can start going to do what you're going to do. It will it'll load your main nib for you. So if your main nib includes a window, it'll push that up as well. And then it starts waiting for events in something called a run loop. So as you can see here, it's a loop. It's basically sitting there waiting for input of any kind, whether that input is network activity, whether that input is touches from a user. All of that, basically the application is sitting there waiting for that input. And you go process that input, and it will continue waiting for that input until a point in time when somebody says, till either your app crashes, which it will not do, right? Or somebody presses the home button, and your app will be terminated, and you will be brought back to the home screen. So we're going to get a little bit into the UIKit framework today. UIKit provides several standard interface elements for you. So buttons, sliders, text fields, labels for rendering text, table views for rendering lists of text. And you've all seen a table view. There are several applications, including the iPod app on the phone, that is essentially it's several cascading table views. UIKit has a way of interacting with your code. I would encourage you, if you're familiar with other frameworks from other languages and you're trying to fit some of those paradigms into this, take a step back and look at how UIKit is trying to, read the documentation and see what UIKit is trying to present to you. We'll talk about some of these things today, something called delegation. But take a step back and see how this fits into your world. And experience will kind of make this a little more clear. But UIKit's been around for, UIKit and AppKit on the Mac have been around for 20 years. So these are well thought out ideas, these are well thought out classes, and I encourage you to take a look at how they're built. So the UIKit framework, this is involved in several parts of your application. It's involved in starting your application. In fact, your application comes from UIKit. It's called the UI application class. And that's what gets started when your app is initialized. UI application is a singleton design pattern, which means when you run your application, there's only one instance of UI application. And you can always get to it from anywhere in your application. If you need to get to your application instance, you can always get to it with this class method called shared application. So if you did an open square bracket, UI application, shared application, closed square bracket, you can get to the object that represents your app. And there's several things you can query it for. But it's more interesting for how it calls you back, and we'll show you those in a little bit. It orchestrates the life cycle, so it manages the event loop for your application and dispatching events to your windows and your views. It manages the status bar, which on the iPhone is the little black bar up at the top that tells you the time and network status. You can actually change the look of the status bar, and sometimes I think you can even control a couple of the things that are in the status bar. Yeah, you can add a little spinner for network activity. And you do that by accessing your UI application object. And also the application icon badge. So if you've seen some applications have, it'll have a little starburst with the number 3 in it, or some number that's custom. The mail app, for example, will have a little starburst that tells you how many pieces of mail have been unread. That's maintained by the UI application. And one thing to note here is that it's very rarely subclassed. So I'm going to introduce you to a concept called delegation. And delegation is a way for you to keep the UI application or other objects, but in this case, UI application object intact. You're not going to change it. You're not going to override it, but to still get some of the notifications and messages that are important for your application execution. So let's talk about delegation. Well, delegation allows for an object or a class to have very contained behavior and to know, to provide hooks to someone else for customization. Okay, so we'll look at the UI application in a second, but it avoids having to subclass very complex objects. And some of the ones you'll encounter over the course of this class are UI text field, UI application itself, UI table view. These are objects, classes that you don't want to mess with, but you want to use them in such a way, you want to customize them. And we use delegation as a way to hook. I'll show you a little demo in a little bit that'll make it a little more clear. The UI application delegate itself, all right, there's something called a protocol, which defines several methods. You get one by default when you create a new project. So when you create a new project, it creates a UI application delegate for you, and it assigns it in your nib. So you're automatically set up to start receiving messages from your application. Here are some of the examples of things that you can get, messages you can get from the application. You could find out when you finished launching. In there, you could do some initialization if you have to. Sometimes you might want to put up a window yourself. You'll get notified when the application is about to terminate. So when the user hits the home screen and it's going to kill your application, you get a chance to do any cleanup, save your database, close down your network connections. You'll find out when the application will resign active. And one example of that is if someone's using your application and a phone call comes in, your application doesn't quit. It'll just resign active, which means it's kind of put to the background while the user is on the phone call. Another thing you can get is handle open URL. So in UIKit, your application can register for a schema, right? So if you could have something that say, HTTP is a schema that whenever you click on something that starts with HTTP, Safari opens. You can have custom schemas that other applications can open your application with. Application did receive memory warning. This one's important. I think we'll actually spend more time on this one later in the term. But we're talking about little embedded devices. And for the size and for what we've seen in the past, sure, they have a lot of memory. 128 megs, I think, is what they have today. But that's still pretty constrained when you're downloading lots of images, when you're doing a lot of web surfing, whatever you're doing. You're still very constrained. Playing music, these are expensive things. So the application will let you know when the system is running out of memory, and it'll give you a chance to release memory that you don't need. We'll talk a little more in a few days about what kinds of things you might want to release. But as a precaution, what would happen is if you don't respond to this memory warning and your system is running out of memory, the system is going to kill your application. So you want to try and be a good citizen on the platform. And the last thing I pointed out that goes into your application bundle is an info.plist file. And there are several things in there that you can specify. You can specify what your icon looks like. So you can tell it whether or not it has a special shine on it, which you see in several iPhone icons. You can define the status bar style. So you may have seen some applications have a gray status bar. Some of them have a black status bar. By setting a key in the info plist file, that will get configured for you properly when you launch the application. The orientation, so if you have an application that's Where's my phone? If you have an application that only runs in portrait mode, which means only in this orientation, you can specify that. If it only runs in landscape, you can specify that as well. You can specify if your app requires Wi-Fi. And what that'll do is as soon as you launch, the system will try and get all the resources ready so that Wi-Fi is available by the time you launch. And then system requirements. So if you write an app that only works on the iPhone and doesn't work on iPod Touch or vice versa, you specify that in the app, and then the app will prevent loading on a system that doesn't support it. And all of these properties can be set inside of Xcode. When you create your application with a new project in Xcode, you'll see that it creates an info.plist file. So I would encourage you, go explore it. There's keys that aren't in there that you can add to it if you really want to. Edit some of them, and you'll see how that reacts. So I want to show you a quick little demo about delegation and the kinds of messages we can get from the UI application, or when they come through. OK, so I'm going to do a very basic app. This is going to be, I think, the last app we show you this term that you have to monitor through logging. We're going to get into views a little bit later today, so it'll get a lot more exciting. But let's look at this through logging, and I'll show you some of the messages that we can get. I'm going to create a window-based application. Let's call this UI app delegate example. All right, so when my project is created, let's look inside of the project file. We get two files, a header and a .m, that are the app delegate files that are created for you. I'll make this a little bigger. That's where you do your hooking up for getting UI application messages. There are a few other things in here. So there's a main.m, which is which basically starts up your application. And it calls UI application main, which really starts the whole process. We won't worry about, I don't think we'll even have to customize this at all during this course, so I won't go into that. A precompiled header file, we don't have to worry about that. There's a plist in here too. So let's just run and see what we get. So our application comes up. And we have blank window. We wouldn't expect any more. I want to show you an example of setting the status bar style in the plist. So let's see. Here are all the different predefined settings that you can have. So here's status bar style, and we'll set it to opaque black. All right, so I haven't changed any code. I'm just changing the info plist. When I relaunch, you'll notice up here, our status bar is now black. All right, easy enough. I'll show you a little bit about the application delegate. So if I open up our main window, our nib, you'll see that it automatically, when it gets loaded, will create this window, which is an empty window. And it has this app delegate object that it's created for you. If we look at, so this thing called files owner, and don't worry about files owner right now, we'll get into it another day. But the files owner in this case is the UI application that starts your object up. And if we look at the targets for this, the outlets, there's a delegate outlet here. And the delegate is already hooked up for you to call your app delegate subclass. So if I click on this app delegate and I go to the class type over in the info tab, it's set up with a class of UI app delegate example app delegate. I chose a poor name for my project. All right, so let's look at some hooks here. Application did finish launching. This one's already set up for you. It basically just loads the window. And it has, I'm going to look at the header now for the app delegate. It has one IB outlet, and that's the window, and that's what's pointed to in the nib file. So if I look at our app delegate and I look at its outlets, you'll see that there's this connection here. I wonder if I can show. Anyway, this is the app delegate here is connected to this window. And that's the connection that's here. So let's just put an NS log to prove that this is getting called. our app was initialized. All right, and now let's implement another one of these delegate methods. I'm looking at the header file for UI application, where it shows you the different application delegate methods that you can override. We're going to look at, let's say, will change status bar orientation. So I'm going to copy that. We're going to go back to our implementation, and we're going to add that as a method. And let's just do a little log here. Will change status bar orientation to, and then we'll print it out. New status bar orientation. All right, so if I hit run, and we look at our logs, you'll see in the console, we already say our app was initialized. Now if I rotate this, oh, I forgot to tell it that it should work in both modes. Is that right? We'll find out. Orientation. Let's see. There he is, that guy. Initial, oh, that's the initial interface orientation. I think I may have to override. Right. Okay, well, let's pretend that I didn't go down that path. I think what I need to do here is I need to tell the application that it's allowed to do certain orientations. And what would happen is, when we set all that up, some of it happens automatically when we start talking about view controllers. I believe that's on next Thursday's lecture. The view controller basically says, hey, I'm a view controller that's allowed to be landscape or portrait. And then what happens is our application delegate will start getting messages that say, hey, I was just rotated. So we would print the log in that case. All right, so let's go back to the slides. Are there any questions about delegation before I move on? Or UI application as a class? Okay. So the next thing I want to talk about is model view controller. And as you see here, if you take nothing else away from this class, from this course, learn about model view controller. It's a very helpful design pattern. When I started learning about it, it changed the way I thought about architecting applications. Model view controller basically says that there are 3 distinct responsibilities for your application. The view, which is what you present to the user. The model, which is the storage of data or the representation of data inside your app. And then there's this third thing up here called a controller. And the controller manages taking the data and presenting that to the view. And similarly, when the view wants to manipulate the data, it's the conduit with which the view can do that. So the fundamental premise here is that the view and the model should never know about each other or talk to each other. The controller is the intermediary that manages presentation and control. So let's look at the 3 little pieces here. So model is the app data and the state of the app. Could be a database. It could be memory that you've created when you launched, stuff you fetch from the network. But it's the data for the application. It doesn't know anything about how that data is going to be presented, how it's going to be presented. It often persists somewhere. Again, if it's a database, you would save it in core data or SQL. It may persist on the network somewhere, which is what you're going to fetch. The same model should be reusable and unchanged in different interfaces. So if you have an application that represents some data set, let's say that's the data representing the population and their voting information. The data itself, the model doesn't know how that information is going to be presented to the user. So that model can then be taken to different platforms. It can be taken to different applications. And it's the premise of this is that it's independent of how it's being presented. Now the view, you should be mostly familiar with. This is what you interact with all the time. It presents the model to the user in something appropriate for the interface that you're using. So if you're using an iPhone, there's view elements that are appropriate for that device, right? That take touches, and there's standard interface elements. If you're presenting a view on a different platform, it may require that you use a mouse. But it doesn't know about the data itself. But it does allow you, the view allows you to manipulate the data, right? So if I have a slider that's changing some value on disk, right? The slider is the view. It does not store any data. Again, if you look at any of these UI classes, UIKit classes, none of them know anything about the data they're representing. But so they don't store anything, right? They're completely dynamic. They're created. They come and go. And they're easily configurable, right? So we'll go back to the table view example. A table view is a view that can represent all kinds of different data, whether it be lists of artists, whether it be the mail in your inbox. The table view doesn't know about the data. It only presents it. So how do you get the data in between the two? And the answer here is controller. And you've probably you may have noticed already that in the examples we've been showing, in the sample examples, we're generally creating an object called controller, or my controller, or other things that we've named it. The controller is basically what tells the view about changes to the data, and changes the data when the view tells it to. Most of your application logic will be in the controller. So if we look at the communication here, the model talks to the controller, and the controller can manipulate the model. The view can manipulate the controller, and the controller can set the value, the view's state, but there's no third arrow in between model and view. They don't talk to each other. So in this case, I have this controller in the middle, okay? And I've got two components on either side. One is our model, and one is our view. The controller has outlets so that it can talk to the model, and it has an IB outlet that can talk to the window. Now the window also it may have buttons, or it may have sliders that can send actions. And we've seen target action, which we'll talk a little bit more about later. But essentially, the actions go from the window to the controller so that the controller can do what it needs to with those targets and actions, or with the actions. So let me show you. Actually, no, I'm not going to show you yet. When we talk about targets and actions a little later, some of this will be easier to show. So I want to talk about Interface Builder and nibs. Now we've all seen Interface Builder now. I think our first example was putting a slider and a text field on the screen and representing the value that came out of that slider in the text field. Well, what's a nib file? It has an extension called XIB. Right? It's the draft. It's the blueprint for the view of your application. In fact, even the icon looks like it was hand-sketched. So you notice Apple designers have plenty of time on their hands if they're stylizing the icons for the tools, right? OK, so the nib files, they help you design the V in MVC. And they help you lay out user interfaces. As we saw, they'll help you tell you where the proper guides are to help you align different elements, make sure they all look good. They'll also let you add controller objects. So when you load a nib, it can actually instantiate your controller object for you. And it'll let you connect the controller and the UI. So if your controller has several different IB outlets, it will let you connect those IB outlets to the proper views in the window or in the view. And it has IB actions, which allow you to connect the view back to the controller. So a little information about how nib loading works. So when you create and save your nib, what it does is it actually creates the object at the time that you save that nib, and it puts it into a kind of deep freeze. When you then load your application, and the nib loads because you've loaded a view or you load your main window, it takes those objects out of deep freeze, makes sure the connections are right, and then you have a usable set of connections and views. It makes sure that all the outlets and actions are connected, so it'll make sure that all your, the proper instances that come out of that nib are proper. But the order in which things are unarchived from that nib is undefined. Which begs the question, if you need to do some additional customization in code from something that you load from a nib, well, how do you do that, right? So if I have a controller and I have a slider in my view, and I need to set my slider to some initial value based on the data or the time of day or whatever it is, the nib doesn't know that. So how do you hook into that? And the answer is with a method called awake from nib. All right, awake from nib is a default implementation which does nothing on NSObject. But whenever your nib comes out of this deep freeze, whenever your nib is loaded, it will call awake from nib to tell you that everything in that nib has finished loading, and now it's safe to do any initialization. You know that all your connections are already wired up for you. You often implement this in your controller class. Again, if you want to set some default states for your views, this would be the right time to do it. And you can guarantee at this point that everything's already connected up. So when you implement awake from nib in any one of the objects that you've subclassed and included in your nib, there's the time to wire up any initial state. Let me do a little example on this. All right, so let's go back to, let's get rid of this. Let's go back to our nib. And let's add a, text field. Or, sorry, a label. Here, let's add a label and a slider. All right, label and a slider. Okay. Now, we need outlets from the, what I'm going to do here is when the view loads, I'm going to set some default values for the slider and the text. So let's make this a little prettier. Let's make it the full width. Oh. Let's leave that label where it is. I'm going to set up IB outlets in my app delegate so that I can have references to those objects in the view. So I'm going to the header for the app delegate. On Tuesday of last week, you saw us do this completely in Interface Builder. I'm going to show you now how to do this in code. In fact, some of you have noticed that the way we showed it working last Tuesday, I'm embarrassed to say, this is a machine running Leopard, not Snow Leopard, and they've changed how the outlets and actions are set up in Interface Builder. But regardless, most of the time you're going to do this in code, so pay attention to how I do this here. I'm going to add 2 new outlets, so IB outlet. One is a UI slider, so I'm going to call this slider. Another IB outlet to a UI label, which is the other view component I have. All right. And then when we go back to you'll notice all I do is save the header here. And when I go back to Interface Builder, and I look at my app delegate object here, it has 2 new outlets called label and slider. So it automatically updates when you save in Xcode. So let's wire them up. We're going to control-click from the app delegate to the slider, and it'll tell us that the only option, because we type-checked it, is the slider. And we're going to add another outlet from the app delegate to the label. So that's the label. And now back to my app delegate. What I'm going to do is I'm going to implement awake from nib. Void awake from nib. And let's just do something really simple here. We'll say when we awake from nib, let's see. Our slider has a range of, if we go to the attributes tab here, we can change some things about it. So let's say our slider goes to 100. And it has initial value of 50. Okay. If I just run this, you'll notice that the slider will come up and it'll have an initial value of 50, or halfway between 0 and 100. But in my awake from nib, I'm going to say slider.value equals 5, and we should see it about 1/20th of the way through. And I'm going to say label.text equals awake. So now when I run, Oh, it's a pretty small label, actually. Let's make it a little wider. And actually, I'll show you some of the attributes really quick. We're not going to get into any detail here, but the label lets you do a few interesting things here, too. I'm going to make it so that it aligns center. And let's make the color blue. Blueberry. All right, so I'm going to run again. And so when we come up, the value of the slider is 5. Remember, on a scale from 0 to 100. And the text label is I'm awake. Okay? So any objects that you implement, any classes that you subclass in and include in your nib, you can implement awake from nib, and at the time that they're awoken from this deep freeze, you can set their initial states then. So that's that. Any questions? No. All right, so something else we touched upon a few days ago is target action with controls, right? If you remember, controls allow you to specify a message and a receiver of that message when certain actions are performed. There are different kinds of actions or events that you can respond to. So in this case, let's go down this list. There's a few different touch events that you can get. You can find out when your control got a touch down event. So when somebody put their finger down for the first time, that's an event. When somebody touch dragged, so if somebody puts their finger down, they get a touch down. If they then move around within your view, you'll get a touch dragged event. And you'll actually get the event itself, which will have some coordinate information. So to tell you x, y, where it was in your view. And touch up. So you can find out if the user lifted their finger and whether they lifted their finger inside your view or somewhere outside your view. You can also subscribe to, you can get events for value changed events. There's several controls that are value-based. Slider is value-based, right? It has a number. A switch is value-based. It could be true or false, or on or off. Other value-based. There's a segmented control, right? So, progress indicator. So these are controls that have a settable value. You can add an action that gets called when that value gets changed. And there's also editing events, which may be more interesting for things like table views. You can find out when the user told the table view to start editing or end editing. So when an event occurs, your action is called. And the way you set up an event is the way you set up a target action is you specify the object that will be your target, you specify the selector that will be called, and you specify what kind of event you want to be triggered. You want your action to be triggered on. So in this case, my object is this controller over here. And when I press that decrease button in the top right, it will, when the touch up happens, it will call the decrease method on the controller because we set it up that way. And we can set this up in Interface Builder, and we can set this up in code as well. Now, when you implement your action methods, there's 3 different ways, 3 flavors of how you can implement it. You can have a selector that takes no arguments, a message that takes no arguments. You can have a message that takes 1 argument, and if you do this, the argument is always the sender. So the object that initiated the method, so the action. So if you set up a target action from a button to your controller, and you press that button, the sender is going to be the button. If you do it from a slider, it's going to be a slider. The other flavor is with 2 arguments, and it's action method with event. The first argument is always the sender, just like it was in the second case, and the event is always the second argument. And the event contains information like the location in the view, the time that the event occurred, the type of event it was. Right, and details about the event that took place. So here are the examples of implementing an action method. You can have a simple one, so increase. If you have a button, you don't really need to know the button. You don't need to know anything about its state. You just know that it was pressed. So you implement the increase method. This oftentimes, instead of returning void, you'll want to return IB action if you're doing this in a nib. And I'll show you that in a little bit. But OK, so this increase method will basically increment something in your model. The second case is where you actually take the first argument as the sender. So let's say this was a slider. We're going to get the value off the sender and take that as to manipulate our model. And in the third case, you can do what you want with that, but this is where you can find out a little more information about the event, the timing, the type of event it was, etc. Another thing, for those of you that have done any Mac programming in the past, you can only set up one target action per control. On UIKit, you can actually set up several. You can have several different methods get called when the value changes for a control. Similarly, there are several different types of events that you can have actions on. So it's a lot more flexible in UIKit than it ever was before. And these things can be set up in code, or they can be set up in Interface Builder. So if you wanted to set it up in code, these are the methods to do it. So this is the same thing that Interface Builder does, but it's more explicit. There are APIs and an enum of control events that you can pick from. Sorry, it's a bit mask of an enum. And you would call add target action for control events. So if I have my controller that, let's say it generates a button. It's not in Interface Builder. It generates a button and it manually adds it to a view. It adds it to the window. I would tell that button that add target with self, the controller. Action is, let's say it's at selector increase. And for control events, UI control event touch up inside, which means when the user lifts their finger, that's when I want to perform the increase action. And if you've set one up and you want to remove that action, there's a matched remove target action for control events. Yes?
If multiple actions trigger, what's the order?
Oh, so the question is, if multiple actions are set up, what's the order? I don't know. It might be undefined. It might be in the order that you set them up, but I don't know. I don't know. Yeah. OK, so before I get into this, which is assignment 2B, I want to talk a little bit about it. Let me show you an example of target actions. Excuse me, right into the mic. OK. So let's go back to our example that we've been working on. And what are we going to do? Well, let's implement some of these actions in our controller, in our app delegate. So I'm going to implement IB action. Let's do this in the header. And then we'll pull them into the code. So I'm going to implement a few actions here. One is IB action increase. Let's do something a little more interesting. Let's say flash window. Okay. Let's set up another one that is IB action print print value, and it'll take a sender. All right, and the third one, so I'm not sure how I'm going to illustrate yet, will we'll say print value with event, UI event. So here are three different types of actions that we can perform. Flash window, print value with event. So let's go implement them. When the user, I'm going to add a button to my view in a moment, that what I want it to do is I want to set the background color of the window. So we'll say window.background color equals UI color blue color. In fact, let's go a little more interesting here. Let's say if window.background color equals blue color, then let's set it to red. And else window.background color, that should be color, equals UI color, blue color. Let's add another one here that says print value. So this one takes one argument, which is the sender. I'm going to hook it up to my slider. So I'm going to say UI slider. We're going to cast it just for clarity here. Slider equals UI slider sender. And we're going to tell our label, text, this is what we saw last week. Let's do it again. And a string with integer, format, %d, and we'll do slider.value. And in this case, let's do label.text equals in a string with format. And let's use the description method that we learned about last week, and we're going to just print the event. Now this might not be very interesting information. In fact, it'll probably be an address followed by some junk we don't care about, but it might tell us some more interesting things as well. And let's look at how I'm going to hook these up. In fact, let's also print out the sender equals and event equals. So 2 arguments here, sender and event. Now let's hook them up. So in my nib, I said I was going to add a flash button. So let's add a round rect button. And we'll name it flash. All right, I'm going to hook this up. So control click to my app delegate. Ooh, why is that not like that? Control I may not have saved. So we're going to drag from the button to the app delegate. And there are the 3 actions that we set up. When that button goes down, I'm going to say flash window. Okay. Now let's take the slider. And what I want to do here is I want to use one of the specific event types. So when, let's say, let's see, that's an interesting one, touch drag inside. So when I'm dragging the slider and my finger is still inside the slider, I'm going to call my app delegate with print value. So it'll tell us what the value is. And just to show this as an example, when I let go of the slider, so we're going to get a touch up inside event, we're going to have that call our app delegate with the event, and it's going to print the sender and the event. So let's hook those up. Now, we should be able to do this again, like I said today, no more logging, right? Let's hit run. Now, if I flash, it changes the background color. Oh, changed it once. Why did that not work? Oh, there's singletons. Right. So let's just do this. This is dirty. Nobody sees this. Counter equals int counter equals 0. Let's say if counter plus plus mod 2. Right. That should do it. This is basically going to alternate, right? I hope. Blue, red, blue, red, blue, red. Right? This is an example where, oh, something happened. Example where we are not taking any arguments, right? We're just taking, there are no arguments, right? We don't care because we're just alternating. So now I'm going to move the slider. So if you remember, as we drag inside, we're going to print the value that we're dragging. So here I'm clicking down, I start dragging, what did I do? I'm printing out a decimal, but I should be printing out a float. So let's fix that. Let's do that. All right, what color, blue or red? All right, red. All right, so as I drag the slider, we're going to see the value change. And that's the drag inside. It takes only one argument, which is the sender. And when I let go, we have it hooked up so that the touch up inside will print in the same label. It'll print the sender and the event. Now the label's probably not big enough, but let's just see. So I let go and it says sender is UI slider. It has a frame, which is the rectangle for that slider. And there's a bunch of information that is too small to fit on. It doesn't fit on that label. But this should illustrate the three different types of methods that we have here, of actions that we have here. One with no argument, one with the sender, and one with the sender and the event. Any questions about target action? We're going to use this pretty extensively in the Hello Poly assignment that you start on. Well, hopefully, you maybe already started on, but it's due next Wednesday. So you should understand this. Okay. So now let's look at the Hello Poly, just really quickly, some screenshots, a little information about it. We'll do a full demo on Tuesday of next week. So this is this week's assignment. It's a full MVC application. You're going to implement a data model object, which is the polygon object, which has a notion of number of sides. And it knows how to, I believe it knows how to describe itself to say whether it's a square or a pentagon. Next week's assignment we'll get a little more into we'll get into more detail about how to actually draw it. It's not designed to be complex. It's just trying to get you involved in creating an actual view, an MVC application. That's the point of this. So you will implement all three of these. The view will be your, what you draw on screen. The model will be your polygon object, and the controller will have the two. Will manage the communication between the two. So when your view, I think I have a UI on the next page. Oh, here. Polygon shape is your model object. The UI kit controls, which we're going to do in the next assignment, are your view, and the controller is what you're going to implement as well. Here's what it should roughly look like, where your controller is this centerpiece. It has a few different outlets. One of them is the number of sides label, which is that top label at the top, an increase and a decrease button, and then the drawing of the shape below. Oops. Sorry, the drawing of the shape below. And then it'll have two actions, an increase and a decrease action. And obviously you notice from the UI that's there are no other controls on the screen, so that's what the view will call into your controller. And you'll have a model object that represents the polygon shape. So there's one outlet, which is the model. There's three outlets to the view. The increase and decrease will be called from your view. So that's it. I think the assignment, the write-up is fairly extensive. You should be able to do it all in one nib file. Generally, what you do when you create a more complex application is you separate your views into different nib files, depending on functionality. So let's take the iPod application as a breakdown. If that was implemented with nibs, the now playing screen would be one nib. The view, the table view would be another nib. Cover flow would be another nib, for example. And what that does is it helps with memory management. But don't worry about that for now. For this, put it all in one nib. It's easier. And we'll talk about view controllers in a couple of weeks. And view controllers are this pretty high-level construct for building controllers, and they're really meant for iPhone apps where each screen is actually a separate chunk of information that you're trying to show. And they have a lot of great uses, but I'm hyping them up, but don't look at them yet. So that's it. Are there any questions about today's lecture? Any questions about the assignment? Any questions about last week's assignment? No? Yeah?
I'm not sure I ever understood. Why are most of the names of things beginning with NS? What does that stand for?
Sure. So the question is, why do several objects start with NS? And this is a historical thing. So let me start with the easy case. You notice UI kit, a lot of the objects start with UI, right? That's pretty obvious. It's a user interface kit. The objects in Foundation, a lot of them start with NS because they go back to the next step days. If you remember in 1996, Apple bought Next, which was a company that Steve Jobs created back in 1986. And Steve Jobs, came back with a coup and convinced Apple that they needed this company, and it was a great thing they did because we got Mac OS 10 out of it, and all kinds of great managers. Hopefully my manager's watching this. And anyways, the reason all these objects start with NS is it goes back to Next Step, which was the name of the operating system that Next used on their computers. So, does that answer? To help you? Any other questions? Historical anecdotes you want me to tell? No. OK, well, we'll see you next week, next Tuesday.
For more, please visit us at stanford.edu.